Hi, this is the Gardener community meeting. This is a recorded meeting, and we publish the recording on YouTube as usual. Today we have two topics. Pablo Chacin from SUSE will talk about a PSC for using SUSE JeOS in Gardener. And then the second topic is from Sebastian about IPVS. Pablo, you can take over.
Hello.
Hi.
Can you hear me? Let me close a little bit this because a lot of light. Yes. Hello, everybody. Regarding this concept of using SUSE JeOS distribution in Gardener. I was trying to prepare a demo. Unfortunately, I underestimated the complexity of recording the demo because unfortunately the Zoom Linux client doesn't allow me to share the screen, so I have to record that. But I promise I will soon post that after the meeting. It's a very short demo, just showing that it can actually it's possible to launch a worker running JeOS operating system. The status of this work since last time we discussed about it is that thanks to the support of the SAP Gardener team a couple of weeks ago, we managed to implement the controller. The implementation is now under review for being merged into the Gardener extension project. When this is done, so far all the testing has been done locally in the local environment. This is something that also was a work that we did together, is to make some enhancement to the local setup so that it's possible to select the operating system image that will allow us to test different images locally, shortening the life cycle, the cycle for testing new images and different operating systems. And once this is accomplished, the next step should be testing this in the integration environment. Unfortunately, I don't have access right now or in an easy way to EC2 or instances for testing, for creating a Gardener cluster. So the next step will be definitely work together and try to set up a test for the use of controller in the continuous integration environment. That's something that will definitely be necessary. More comments is that based on this work, actually the implementation of this controller was to a long extent based on the implementation of the Ali Cloud controller. So I found there was a lot of code that could be reused for multiple controllers. The pull request that is now under review basically creates a library for controllers that only requires a template for transforming the cloud config that is provided by Gardener into a operating system specific format without requiring any additional complex logic, just using a template. I think that this is valuable because different versions of the same operating system or different operating system may probably just require different templates that minimize the code that is required for implementing those or for supporting those operating systems. That is the status. So it's not only the implementation of this particular controller, it's also a first step toward having a more generic controller. Hopefully this will be soon available in the project, and as I said before. the next step will be testing this into a proper continuous integration environment. And that's basically from my side. As I said before, as soon as I can, I will share with you the recording of the demo. It's a short demo, just basically shows a local environment running SUSE cluster with a worker that runs JeOS, and you can see it can be used. I have deployed application there, so it is fully working. Controller, through working worker node. I also has tested things like making minor changes in the operating system configuration, and seeing how these changes are reflected automatically in the node. So it's also all the cycle of not only starting the worker but also maintaining the configuration over the life cycle of the worker is also possible. It's tested. And that's for my side the private product status. I just again thanks all the Gartner team in Wardrop for the support they gave me to move this forward.
Thank you, Pablo. Are there questions? Actually, I have a question. Those images, are they available on the cloud providers already?
The one I'm using for local development, not, because it's a private image. What I will do is to share in some repository. I need to check with my manager how to do it in a better way. I would say the sources of the image. It's very simple to create. It's just 2 minutes and one single command. You can create a local image. Regarding the official images, they are available, but not to the public, I understand. I think that the SAP Linux Lab guys has the access to those images. They are available in some specific region. That is important because the images in Amazon are region specific. So if you look at the image in another region, you won't find it. That's probably why you haven't seen there, because you need to know where they are. I don't have this information because this official image for EC2 is being developed for the team who create the official image for SUSE. All the work I've done so far is more for developers and for testing new versions. I don't expect any problem once we start using the official images, because basically the difference is that that image is created for the specific environment, so have some other packages for integrating with the EC2 environment, while the development JeOS image I created is very simple, only have a few packages that are required for Gardener to work.
Mm-hmm. And is there already a timeline when official images will be available?
My understanding is that the step is we should, once this controller is integrated in the code, and we can arrange, figure out how to do this integration test.
Mm-hmm.
Start testing it. I mean, once the images are tested by us together, in particular by the SAP Linux Lab, who has been driving all this development of the image with the SUSE team that will maintain those images, official images, and the Gardener team for the support of the continuous integration environment, how to test there.
Mm-hmm.
When this test is done and we are happy with the result, my understanding is that then this image will start be available.
Okay.
It's also important that that's part, unfortunately, I don't really manage, is that there are also considerations regarding the official maintenance. I think this is still be available for development, probably not for production support, because
sure. Yep.
official, you know how complex it's just to offer officials seal of approval is much more complicated. That's why I've been working in this development version of everything, because just to shorten the development cycle. Any other question?
That seems not to be the case. Thank you, Pablo.
One final comment is that I also, from my visit to the Gardner team, there was also requirements for supporting other version of SLES. I mean, JeOS is basically a streamed down version of SUSE Linux. One of the objectives is also start testing those images with the same controller, because I don't expect any change or any major change. It's just to be seen, but in principle, there shouldn't be, because our basically distribution of the same core operating system. So once you get the right image, that shouldn't be an issue for the controller to
So
provide.
they would just differ in the number of packages being installed, right?
Yeah, in the core image. I mean, once you get there, if we find any problem, that will probably take us to the next step in the development, which we already commented during my visit, is that I'm planning to provide support for, I would say, patching the configuration. So if for whatever reason, for one, you need to add some configuration attribute or something additional to the core Gardener configuration, instead of developing a new controller, we enable like to patch the final configuration. That will also make easier to maintain slightly different version of the same configuration without having to maintain different controllers. And say this controller use this image plus this additional configuration. That's something that I was started looking around. I hopefully once we get this integrated into this first version, the next iteration I hope to start doing quickly is this ability, because we know that there might be minor changes in the Docker configuration and stuff like that that probably you need to tweak. So that's also all this is important for us, just to make this maintainable over time, instead of having proliferated the number of controllers, just having one common controller plus different configuration templates plus additional customization that maybe applies only to one specific cluster. That's more or less what we are envisioning to do, because we have seen this kind of situation in our conversation that are like a very specific use cases where you require some tweaks. Okay, it's more or less the roadmap that we have for this controller.
Thank you, Pablo.
Welcome.
Then we can go to the next topic. Sebastian, you can take over.
Thank you, Matthias. Okay, let me share my screen. Okay, can you see my screen?
Yes.
Okay, then we're fine here. Thanks. So we from Gardner team offer now also shoot clusters, which can be run in the kube-proxy mode with IPVS. And first of all, I want to give a short recap, because I guess not everyone is familiar with IPVS, what it is, and then I will show you what we have to change in the shoot spec and how we can run the cluster in IPVS. So first of all, here you can see the agenda. I want to give some background information. Then I will come to the IPVS forwarding rules. There are 3.1, LVS, nothing, direct routing, and IP tunneling. Then I will come to the requirement, what was needed to implement it in the Gardner, then to IPVS in Kubernetes, and at the end, compare it to IP tables and give a demo. So first of all, there's some terminology which is important if you want to understand IPVS. First of all, there's a Linux director. This is a host with Linux and Linux virtual server installed, which receives the packets from the client which are coming in and forwards them then to the real servers, in Kubernetes case to the endpoint, and it acts as a load balancer. Then a virtual IP is an IP address assigned to a service that a Linux director will handle. And a virtual service consists out of three things: an IP address, port, and a protocol. In our case, most of the time TCP or UDP. And there are also firewall marks. And with these firewall marks, you can combine multiple services into one service to just expose one to the outside world. IPVS is built on top of NetFilter, and it's in the Linux kernel since version 2.4. And there are also three forwarding rules: nutting, direct routing, and tunneling. And the default routing, which we also currently use in our Gardener, is direct routing. In general, you use nutting for private networks and tunneling or direct routing for LANs or WANs, depending on. So how is nutting working here? So a packet comes in from the internet right up, then it goes to the Linux director, which has a nutting table, and then is sending the packet to one of the real servers. Yes, and below you can see how we have to configure the Linux director. First of all, we have to enable in the kernel IP forwarding. Then we have to bring up an interface which exposes our virtual IP. This could be done with ifconfig or something else like IP. And then we have to define our service. This is the third command, IPVS RDM -a, which adds the service. And then -t is just the TCP service. You can see the IP address of our virtual IP and then the port. And the two lines below, we add our endpoints, which we want to route, and the -m stands, in this case, the last option for masquerading. What is different, when we do nothing, the packet goes the same way out over the Linux director, then it comes in, and with the other two forwarding options, the packet goes directly back to the user without going about the Linux director. What are we doing here? So when the packet comes in, we are looking at it, but the Linux director does not directly inspect it. It just looks at its table and then also adds second MAC address header, and then it's directly routed to the real server. The configuration is similar to the one we've seen before, just the flag at the end has changed. So the -g stands here for direct routing. And if we do IP tunneling, which is the third forwarding method, it's also similar, just instead of adding an additional MAC header, we are adding an additional IP header, and then the packet goes to the real server and directly back in the internet over the Linux director. So what are the requirements, what we need? So we need a few kernel modules, IPVS, RR, VWR, and SH. These are the schedulers. There are different load balancing scheduling methods in IPVS which we can use, and we also need the contract module. This could be loaded with modprobe, or in our case, we just included host path lib modules, which contains those, our container. So IPVS, this was about IPVS in general and how does it work in Kubernetes. kube-proxy watches the API server for services endpoints, and when it sees a new service or pod popping up, then it generates correspondingly the IPVS or IP table rule, depending on which mode it runs in. IPVS is used to expose an entry point service with a unique virtual IP, as we have seen, and all traffic is going through this endpoint then to the physical server or real server. In our case here, one of the 3 pods. What is the difference in general between IPVS and IP tables? IPVS provides better scalability and performance for large cluster because we don't have to go until or through all the IP table change, which could be large in case of Kubernetes when we have a lot of nodes and services. And IPVS also supports health checking of the real server and connection retries. And below here you can see a list of the different scheduler which are provided by IPVS. We are using currently around drop-in, but there are also a lot of other schedulers which are pretty famous, like source hashing, which can also, when we come to really, really large clusters with a lot of services, pretty nice in performance. So then I want to give a short overview. So can you see it? Or
No.
my terminal?
I still see some distorted slide.
Wait, then
the text demo on it.
Then I probably have to close PowerPoint.
No, it looks like you're unshared. Now we can see it, yeah.
Yeah, okay. This is just the shoot spec, which is all familiar for us, and what has changed is only a pretty small change. Now in the Kubernetes section of the spec, we have a kube-proxy entry, and here we can change IP tables, which is the default mode, and if we don't want to use it and use IPVS instead, we just enter here IPVS, and then we can run it. So
and you probably also need to install these additional modules, right?
The
or is that already available?
No, we just have to do it in the Gardener. Everything is included, so we use the modules from the node, so they are in the kernel of the node, and we can directly use it. So then if we exec in a pod with IPVS, wait, I can enlarge this. So hopefully you see it.
Yes.
Okay, so currently we are in the Calico node, and now if we want to look at it, there's some command. It's mere to IP tables, and we can see here also entries. For example, we see here the Kubernetes service entry, which is our virtual IP, and it's directly routed to this endpoint. And here you see the number of connections which are coming in over time. And if you add additional services, they will all pop up here. In our case, most of the service until this one is a DNS service is TCP, but it's working fine. So if you want to try it or test it out or want to use larger clusters with a lot of services, it's pretty nice to use it because it will save a lot of time. So do you have any questions or comments to IPVS? Otherwise, there are also in Kubernetes, or there are different alternatives like Cilium, which is using eBPF. And I mean, it's not clear in which direction the Kubernetes community will go, if it's either eBPF or IPVS. So we will see that in the future.
So from your point of view, the biggest difference is performance and scalability, or?
Yeah, if we are using a lot of services in the cluster, because the IP table rules will grow, and after you have 10,000 IP table rules, it will be pretty long for a packet if it, or the kernel if it has to look for all. And in this case, we should use eBPF or Wasilium or IPVS, which we are currently providing. So.
And this can then be decided per shoot cluster.
Yes, on a shoot cluster spec. So the default mode is IP tables until now, and yeah. Okay, then that's it. Thank you for your attention. If there are no more questions.
Thank you, Sebastian. Do we have any other topics? Seems not to be the case. Then thank you to the speakers and see you next week on Friday. And next week we switch to summertime in Europe. So please check again if you're on a different time zone. Thank you. Bye-bye.
Bye.
Thank you. Bye.